Hello.
Hi, how are you?
Good. How you doing? Hey, Lisa. How are you?
Good, good.
Good.
Hi,
Hi, Tess. How are you?
good.
Oh, Masika let me know that she may be joining a little later, so to feel free to start without her.
Okay. No problem. I think Katie's with us and Lila. Hello, Katie. Okay, Lila's staying muted.
Okay.
So, Katie, are we expecting David and Marina?
Marina cannot make it. Lila, I know she's going to record it so Marina can, observe it at a time that works for her. And David is supposed to come, but he works in a showroom and he never knows exactly when customers are coming through. So we'll see if he comes.
I guess it's a good thing customers are coming through.
Yes.
That's important. Yeah, no worries. Hi. Shall we give David a few more minutes?
I think we can start. I think it's fine.
Okay. Well, so the process that we're going through here is in the design phase is the preparation of schematic design based on what we've learned from both the survey and the geotechnical investigation. And once we have a design direction that everybody loves and we believe we can afford, then we'll prepare construction documents based on that direction. And those construction documents will be priced by some contractors to get competitive numbers. Hopefully we have one that's within the budget, at least one, and we can sign a contract and go build this. So this is the schematic design that we've developed. And we've learned a lot from the topography survey as well as the geotechnical investigations. And maybe we can flip to that. I think everybody's familiar with the project site and where it is in the world. Lower DeHaro between 24th and 25th, and the images of the site. Very familiar with. And let's keep going. We've been sending this out to contractors, so we included some of this for their information, really, so they would have a sense of the context. So the survey is teaching us two pretty important things. One is that as soil has eroded down the slope to Lower DeHaro, the narrowest point of the road is about 15 feet wide. That's where the bullet number one is. And then the slopes in general are about 1.5 to 1 slope. So in other words, for every 1.5 feet horizontally, it goes down about 1 foot vertically. And as you know, but just looking at it, you can tell it's steep. Mathematically, that's pretty steep. Sort of steeper than, but there's a term called angle of repose. And depending on the soil, slopes are stable at a certain angle of repose, again, depending on the soil. In other words, like a sandy dune is not very stable at a very steep slope. It always erodes and washes. Really stiff clays are more stable at steeper slopes. So these soils are sort of a sandy loam, and 1.5 to 1 is certainly steeper than the angle of repose would be for a soil type like this. So these are the soil borings that the geotechnical engineer captured. There's 8 of them. And I think the the important thing to understand when you read these, just a quick takeaway, is that you can see there's always sort of a line drawn, and there's no soil borings or soil information shown below that line. This is the surface, 0 feet depth. This is 1 foot, 2 foot, 3 feet, 4 feet, 5 feet. So at this boring, where that line stops, that means that's the end of the topsoil layer. And below that is rock. And so what we've seen in all 8 of these borings is that the depth of topsoil is somewhere between 6 inches and 2 feet. And then below that is rock. That sort of explains why the succulents are doing really well. The trees are doing better as you go up the slope. The topsoil is a little bit steeper as you go up the slope, and the deeper the topsoil, the better trees do. But it also tells us a few, or at least one very important thing, and that is that we're going to have to excavate a lot of rock when we build this wall, and that gets rather costly, which you'll see here in a moment. So these boring number, sorry, Faye, could you go back there? So boring number 1 is right here, and this is the sort of profile, the log, what they call the log, of soil boring number 1. So at this particular moment, the topsoil depth is about 1.16 inches, roughly, and then it's rock below there. And you'll see how that sort of changes as we flip through the rest of the boring logs. So this is bore location number 2. The soil depth here is a little over 2 feet, actually, which is great. But again, on number 3, we're back at about 16 inches. Okay. And number 4 and number 5, soil depths are once again about 16 inches, and here they're 2 feet. And number 6, the soil depth is 12 inches, and number 7, soil depth is the shallowest, like right around like 6 inches, maybe 4 inches, actually, is what I'm saying. And then number 8 is only about 12 inches of soil. Oh, sure. No, please go ahead. Right. Well, so that rock is, nobody really knows how stable it is. And the serpentine rock is, by its nature, sort of a fractured rock. So, I mean, you could probably do it. It would probably last a little while, but it would also probably continue to erode. Or fall apart, sort of flake, if you will. So there doesn't seem to be a lot of confidence from the geotechnical folks that we could just use the rock as the retainer, particularly since we have this layer of topsoil on top of it that's sort of migrating downhill. Yeah, well, we had the same question. And, yeah, I mean, you still have to sort of retain the topsoil, or it's just going to slide off and continue to find its way onto lower DeHaro. But the good news is that, when you have rock on the backside of a retaining wall, the earth is relatively stable, right? So it's not like you have to build a structure to retain huge depths of soil and the hydrostatic pressure, the water pressure that comes along with that. So that actually is helpful, because there is a structure there that's retaining most of the weight from topsoil and everything else on the upside of the hill. So I guess it's a good news, bad news thing. Okay, so so we put together sort of 4 design options here, and I think it'd be great for Faye to run through these with everyone. And then let me just sort of summarize what they're going to try to accomplish. So, there was many objectives here. One was to retain the slope and grade and create a stable edge to Lower DeHaro that does a great job capturing pollutants and runoff and improving water quality. And then the second, major criteria was to see if we can widen Lower DeHaro to make it potentially an accepted street by the city of San Francisco. So we're going to show you 4 options, 2 of which are using gabion walls, 2 of which are utilizing a different system that Faye has uncovered during the American Society of Landscape Architects conference in San Francisco, the 12th of November. Pretty innovative. So Faye, maybe you can walk through these.
Sure.
Yeah.
Great. So option 1, this is a design for a gabion wall along the street, and we're trying to obtain the street width to be accepted by the city of San Francisco. So here's the plan. So now we have a survey. We know all the real dimensions of the street. So according to the survey, the current street is about 15 feet to 15 and a half feet wide. So in order to be accepted by the city, we need 20 feet from curb to curb, and then plus a 12-inch bioswale. So from the curb to the wall, really, we're looking at a 21 feet width. So this is a plan that shows if we widen the street, this is how much gabion wall unit that we need. So we break it up into 2 sections. This is the south portion. As you can see, at the very south end, which is the low point of the street. So we have this infiltration planter right here. That is about 162 square feet. So this is going to be obtaining all the water, and then we will have a drain connection to the existing manhole. So in order to create this flat area, we need a gabion wall around it. So the gabion wall starts at this corner. So in this diagram, you can see all the yellow boxes. These are 3 basket high gabion wall. So each of them is 18 by 18 by 36. So 3 basket, that means it's about 4 feet and 6 inch high. So we're trying to keep the top of the gabion wall level. So you can see we are terracing the different sections of the wall. So we start at top of wall at 185 for this portion going south. And then we raise up 1 basket to be at a level of 186.5 to hold the grade. And then we go another basket high to 188. So eventually till here, we have 189.5 top of wall. So this is based on really, when we widen the street, we need to cut into the existing slope. And this is roughly where we want to keep the existing grade behind the wall. And as you can see, we have, we're trying to minimize first the rock excavation, and then second, also the grading behind the wall. So we're trying to limit it, grading behind the wall within 24 inch. So you can see this green area right here. For this big area that we're disturbing the grade is where we have all this wood terrace right now. So this area is super steep right now. So once we cut into the slope, we need to regrade it to make it more acceptable so it's not subject to erosion. So you can see we have a big area of the green that is we're regrading the slope.
And I'll just mention also by regrading it, we don't have to build the gabion wall as high. If we didn't regrade it, we'd have to build the wall higher.
Right.
Yeah.
And also we're trying to preserve as many existing trees as possible for this sycamore tree by the infiltration planter here. We're really trying to make sure we keep the existing grade as close as possible so that our wall is not going to disturb the tree roots. The blue? Yeah. Yes. Yeah. In order to, because this is the area really subject to erosion, and that's why we have all this wooden retainers here. So yeah, that's the area that really needs the wall to stop the erosion.
Yeah.
And then the northern portion, again, this area is mostly 5 basket high. And then we already tried to minimize the amount of gabion baskets by sloping the top of wall at 0.4% so that we can have less gabion baskets. But still, this area, it has a very steep slope that we really need a very high wall to hold the grade. And the scope. So this is the bench, existing bench. And that huge yucca is right here. So this is the portion. So here is a typical section at a 4 basket high wall. So you can see, let me pick a color here. So right now, this is pretty much the existing width of the driveway, the street. And then we have a gutter and then curb and then sidewalk. And then the existing grade is doing something like that. And based on the geotechnical report, we have, between 6 to 24 inch of topsoil on top of it. So right now it looks like this. And so in order to widen the street, we need to really find the narrowest point along the street and then saw cut that existing asphalt right here. And then we need to excavate all that rock and topsoil. So this is the topsoil that we need to remove in order to widen the street. And then below that is really the rock that we need to take out to remove. And then after all the excavation, we can put in drainage gravel for the gabion wall, and then Inca-drain is a drainage material that can help drain the water from the slope through the drainage gravel and then into the pipe. And then we have this gabion wall baskets, battered, laid on top of each other. And we have this 12-inch wide bioswale to pick up the drainage from the street. And then a 6-inch wide concrete curb. And then we patch really the asphalt street to the existing street, limit of street. So based on our research on the city of San Francisco standard details, so basically the driveway is made of 2-inch of asphalt concrete wearing surface and then 6-inch deep of black base. So we will match that so that we can widen the street from this curb, the edge of this curb, to the existing curb. That's 20 feet. That's the goal.
Let me mention one thing too. Currently, the existing street drains this way. It drains west back to this gutter. But we think it would be smart to once we find the joint that we're cutting to, that we slope the paving to drain this way. So we're putting as much water as possible into the bioswale and sort of maximizing the water treatment that results.
And also, when we excavate part of the topsoil, we're trying to salvage some of it. So when we do the excavation, we can stop right here. And then once we put the wall in, we can put back our topsoil here at the back of the wall. So then we can plant on top of it. Right, so this is the current condition. We only have a 15 feet or to 16 feet wide street. And this is what after we widen it to be 21 feet from curb to the wall, and then plant on top of at the back of the gabion wall.
Yeah, at points, that's right. But remember, 7 feet 6 inches is the height from the bottom of the wall to the top of the wall. And a portion of the wall, up to 18 inches is going to be buried. 6 to 18 inches. Well, 12 most typically.
Yeah, 12 to 20. Yeah.
So
we're trying to keep the top of the gabion wall level, and then the street is sloping. So at some point, it will be buried more.
Yeah.
And it's lesser height. Yeah.
So the heights of the walls that you see are what's the total height from very bottom to very top, not necessarily what's above the street. But you're right, it's probably taller than that. Yeah.
Okay, just quickly looking at this material is the gabion wall. So I met this manufacturer at the ASLA conference, and I looked at their gabion. So this is we're using like the welded ones. They're not, so they will be rigid, not the, the net kind of gabions. And then we got the pricing from the supplier, and then we incorporated into our cost estimate. And then we also found this backfill supplier. So the stones, gravels going into the gabion baskets. We also get some pricing from them. So they are pretty real and it's pretty current. They're all incorporated into our cost estimate. So this option A here, which is assuming that we widen it to be 20 feet wide, accepted by City of San Francisco. So the estimated cost is 180, 264, is over budget. I think the mainly cost is that in order to widen the street, we have to excavate a lot of rock and also cutting into a lot of slope, and then the wall has to be very tall. I think that's driving the cost here. Scott, do you have anything to add?
No, you're exactly right. That's what's driving.
Yeah. So by looking at all this number, we're thinking, okay, so we can we're really over budget, and what can we do to reduce the cost? And so this option B is really like, what if we don't go 20 feet wide for the street? That means it's probably not going to become a accepted street. So this option is looking at from the curb to the face of the wall about 17 feet wide. So right now it's about 15 to 16 feet wide. So this is what we're shooting for. So the plan is pretty similar to the option A. But you can see because we're cutting into less of the slope, we have a bigger area for the infiltration planter. So right now this is looking at a 224 square feet. So we are looking at, overall, we're looking at gabion wall, like 1 basket to 3 basket high of a gabion wall. Again, part of it will be buried underground. So you're looking at about 12-inch to like 3.5 feet from street level. So this is the south portion. The design is similar, except that it's closer. The street is narrower. One feature here is we're trying to reduce the amount of gabion baskets required. So we're looking at some site photos and see, some of the rock cropping, as you mentioned previously, that can be used as part of the retaining. So you can see at this number 9 area, we stopped the gabion wall to allow the rock cropping to retain that portion of the grade. We could also, in order to stop the soil seeping through between the rock and the basket, we can notch the rock a little bit, and then so that the basket can go in.
But let me mention something while we're here, if I can. If you guys can see this dashed line here, that's the edge of the existing asphalt currently. So we sort of used that line to determine the limit of, well, where we would saw cut the existing asphalt paving And then that defines then the extent of new asphalt paving. In this solution is only about 16 inches or so. And when we get to the south half, I'll talk about the logic of what sets up this edge, which generates the 17-foot dimension.
You mean the north?
But the north, yeah. The north
Yeah.
section. Well, let me talk about that right now. So you can see here's the dashed line of the edge of paving. So we basically use that line to establish this width. So the street paving from this point south would be no narrower than what is the norm out there right now, or the not the widest moment, but pretty much the widest moment out there right now. Did that make sense? That's much better way to say it. Yes, thanks.
Yeah.
Okay, Vic.
Mm-hmm. Yeah, so for the northern portion, we're looking at mostly 3 baskets high. So it's 4.5 feet. So compared to the option A, which is 7.5 feet, we have a much lower wall because we're cutting less the slope. And then on the northern portion, we also from our site visit see this kind of rock cropping that can be used as a retainer to reduce some of the gabion wall we needed. So this is a typical section that's looking at 3 basket gabion wall. It's it's similar to the option A. The differences is really, the street width is narrower. So from this edge of curb to the existing curb, this is running 17 feet wide instead of 20 feet. And we keep all the other dimensions really the same. So we have 12-inch wide bioswale, and then our wall is battered. So this means, we are cutting less of we're removing less of the topsoil, and also we're cutting less the rock. So that's where we can save the cost. And also we're patching a smaller amount of asphalt, about 16-inch wide. So this is where we only need two gabion baskets. So less of an excavation, and that where we can save some money. So this is looking at the infiltration planter area. So on the left-hand side is the upper DeHaro, and then the right-hand side is the lower DeHaro. So there's a grade that we need to pick up, and we also have existing tree to protect. So we need gabion wall around this infiltration planter. This is, currently the slope is going something like that. We need to cut back the topsoil and excavate the rocks to put in this infiltration planter. And we will need to put in a drain, overflow drain pipe down, so the water, if there's a storm event, the water is going higher than the street level, it will all flow into this drain structure. And then we also include the cost for boring this pipe to connect to the existing manhole at, I think, DeHaro and 25th, so that the overflow water can go to the drainage structure. So this is looking at a lower wall with some rock cropping. So the width is 17 feet from face of the wall to the curb. So the option B, the price comes down to 163 to 65. So we still have a gap of 61 and 523. But it's significantly down because of less excavation and then less gabion baskets needed. So, so by exploring these two options, during the design process, I was able to talk to a supplier. They have this green wall system that's pretty affordable and easy to install, and then may reduce the amount of money that we need to excavate the rocks. So here comes the option C. So this is looking at, we're trying to make it an accepted street. So it's 20 feet wide, but we're changing the gabion wall to a green wall system. So this is a brief introduction of this product. It's called Flex MSE. It's basically a bag that's filled with sand and compost. And then they are laid together stacked together as like a gravity wall, and then having this interlocking plates between the bags. So this is a photo of their application, some projects. So the left-hand side is after the placement, and then you can plug in plants in the wall afterwards, or you can hydro seed. And here's another photo of one of their projects. And this is how it may look after the plants are established and thriving. So what if we replace our gabion wall with this Flex MSE green wall? So basically, in this scenario, option C is pretty much the same as option A, but we switch the gabion wall to be this Flex MSE unit, the bags. So the wall height will not change, but because the bags are only 5.5 inch tall, so we will need more bags, but each bags are cheaper. So this is the same as the option A. So we're looking at the wall height still the same. So it's 4.5 feet to 7.5 feet tall. And so here's a section for that MSE bag, Flex MSE bag. So basically this is 5 and this is 12 inch wide. And then by 5.5 inch tall. And they run about 30 inch long. So this will help us reduce the amount of excavation we needed. So basically, when we talk with them, we can excavate our rock right here. And then put in our drainage and supporting gravels, and then lay the bags in. So every 2 or 3 bags, we need a geogrid that we can really nail it into the rock. So that helps a lot with stabilizing the wall and also reduce the excavation. So this is a typical section looking at a around 7.5 feet tall green wall. So we reach out to the manufacturer and also the supplier. So we have a local distributor, and then we got some pricing from them. So this option C and also the option D are based on the very fresh quote from them. So these are some photos. This is when they do after the installation, they put in the hydro seed, and then after 2 to 4 months, the plants are thriving.
I'll just mention that MSE stands for mechanically stabilized earth. And it's a technique used all over the world in building roadways and highways and things of that nature. You can see in the upper left-hand image, they're building a roadway. And when there's fill required, the fill is placed and compacted and usually stabilized with like cement. So the earth becomes stabilized. And then there's just a surfacing that goes in front of that stabilized earth so that it isn't subject to rain and sun and everything else that might degrade it. And in most highways, that's done with precast concrete. But I think what's interesting about this is they've developed these sort of grow bags that are used a lot like sandbags to create the surfacing of mechanically stabilized earth and then they can be vegetated so that, it's a greener solution to retaining grade. The other really great things about this from a water quality perspective is that these bags are very pervious, right? So water is going to flow through them. That's why plants do so well. And it'll act as an incredible filtration system for runoff and sediment and pollutants from uphill. So this is, I think, a great find, actually.
Mm-hmm, mm-hmm. Yeah. So if we are like, if our wall can be a real green wall, that will be, the wall will disappear. Really, you won't see that 6.5 feet tall. You won't have that feeling compared to the gabion wall.
Good.
Okay, so yeah, so based on all the numbers from the suppliers and then the contractor, for this option C, we're looking at $215K plus $822. So we still have a gap of $114 and $80. Again, we have less excavation, but still because widening the road, we still have to do some excavation. I think that's where the money really drains. Okay, so then option D is we're using this green wall, but we're not widening to 20 feet wide. We're keeping that at 17 feet wide. So this is similar to option B. We're just replacing the gabion wall with this flex MSE wall. So the wall height is still the same. So this is looking at like a 4.5 feet tall wall, which I think is the highest in this option. So the highest is going to be like this. Again, so for this, I think if we have the wall like below 4 feet or around 4 feet, we don't need to do that geogrid, that nailing into the excavation, into the rock. And so we have less cost. We don't need to buy that geogrid. And we can plant the wall to make it a green wall. So this option, we're looking at $123K plus $976. So we have a gap of $22K to fill. So here's just a summary of all the materials. So this gabion material we talked about before, the fill go into the gabion wall. And then this is the bioswale gravel. So we have a 6-inch layer on the top, and then we have drainage gravel below it. So this is a supplier that can provide this material. We estimated about $30 per cubic yard. And then this is some planting that can go into the infiltration planter. And we can definitely have succulents especially on top of the wall. And if we're doing green wall, we can also plug them into the bags. So this is the Flex MSE wall that I showed you before.
So I want to
hydroseeding, yeah.
Oh, go ahead, Diane.
Yeah, so this is the application for hydroseeding. So this will require some maintenance, especially for when they're establishing. So during the construction, I think the contractor, they will do a 90-day maintenance period. So they will have to water it to make sure they stay alive. But then after that 90-day, I think we will need the community group to hand water it twice a month for the first year, so that make sure they really establish their roots inside to make it a real green wall.
Can I add a few things?
Sure.
So, there's we'll show this in a minute. There's a native seed mix that's sold throughout California. This one that's composed of 3 native grasses: the red fescue, the Mokolum fescue, and Idaho fescue. These are all weeping native grasses, and they're evergreen. And hydromulching or hydroseeding, I don't know if you guys are familiar with it, but basically you mix seed up with like a mulch into water, and then it's sprayed onto the wall, just like that photograph shows in the lower left. And then we're suggesting here that we include a 90-day maintenance period in the contractor's scope of work. Then he'll be required to water it. My guess is in 90 days, the hydromulch seed is going to look a lot like the bottom right image. It'll be germinated and up. And if we have a normal year, everything should be just fine. Even if we have a freeze, or close to a freeze, everything will be fine. And then some supplemental water, after the maintenance period would be helpful. But these grasses are pretty self-sustaining. I think because the wall is facing west, we should have adequate light to keep grass healthy and alive. But as Faye mentioned, we thought it'd be interesting to, think about hydroseeding about 80% of the wall surface, but maybe in the other 20%, we can plant little 2¼ inch plugs of sedums like that. Yeah, that image shows. And they really just cut a little slot in the bag, like a little T-shaped slot, and then stick the plant in there. And I think also within 90 days, sedums would be established at the point where, they wouldn't need a whole lot of water, just like the ones out there now don't need a whole lot of water to be healthy. So that was sort of the planting notion, knowing that we can't afford to do irrigation, or, have the capacity to do it within the grant. Right. Mm. Right. It's very cool. And when they do irrigate these walls, and that's most commonly what's done, the drip tubing is really just stapled like every third bag. And then it just soaks the bag, and then the roots get moisture and everybody's happy. I think there's probably an image of that in here somewhere, I would think. Is there one, Faye, that shows irrigation tubing?
No, I remember seeing them on their website for sure. They have a lot of image like that.
Right.
Right.
Yeah, I'm glad you think so. We do too. We think it's really cool, actually. And but part of the challenge we've been sort of trying to chase down here is that this product hasn't been installed in the Bay Area yet. And that's good and that's bad, right? The bad thing is, well, let me just say this company is based in Vancouver. So they've done a lot of this in Canada, Texas, Europe, all over the place, but not yet here. So that's a good thing, I think, on many levels. One being, I personally don't know of a better way to use a retaining system to improve stormwater quality. This would be very effective at that. Not to mention it's green and it's beautiful and it creates habitat. That's all awesome. The challenge is that there's not yet a contractor here who's done this. So we've been doing a lot of phone calling and Zooming and trying to bring a couple contractors sort of up to speed on this, so we can get a price we can depend on. That's still in progress, by the way. So that's a good question. They might love it, or then they might. The bag itself may be enough of a barrier that they can't get into it. Yeah, that's a good question, though. Yeah, that's a pretty cool. That's a pretty cool idea.
Mhm.
This blend of grass that you see here, I broadcast in our yard here in Mill Valley about not even a year ago, and it came up in 3 months and it's doing beautifully. Leaps and it's beautiful.
Mm.
Yeah, I mean, grasses love sun, right? So the more sun, the merrier, as long as there's enough moisture, for them to keep up with. growth. But I think it'll do super well on this western facing wall. Yeah. Yeah, but let's go. There's some other points here we probably need to talk through if we can go through these. These are also very important. But every contractor we've talked to is a bit freaked out by how they're going to build something here. So maybe Faye can walk through these construction staging ideas.
Sure. Yeah. Right. So we've been talking to contractors, and then they've been on site a couple times, and then just looking at, we already have a very narrow street here, and then where we can store the construction items, materials. So this is something that we have been talked to the contractor, and it seems like it works. And also this will also be part of the, reducing the cost for construction, because if they need to find a far away area for storage, then, there's more cost related to that. And if there's more, traffic controlling that they need to do, or safety measure they need to do, that's also a cost related to that. So this is what we have been thinking. So number 2 is where we are thinking that we can use that parking spots for staging. This is about 5 parking space. So if we can use that area for about 2 months during the construction, so they can provide this area for the contractor to store all the materials and equipment. So this is only about 400 feet away from the site. So that's one option.
And for instance, like if we do the bags get delivered to the site. The soil that they fill the bags with, which is about 2/3 sand and 1/3 compost, is delivered to the site. And then the contractor is going to have to fill the bags and bind them. And so having a space to do that would be great. And number 2 provides a perfect opportunity for that. And then, they also have to have temporary facilities, toilets and things for their workers. That's a good place to keep that. And the contractor would be responsible for, erecting a temporary construction fence that would stay up so things are secure, and then remove it, once they're done. I think both, actually. It'd be wonderful if you guys could talk to neighbors and see if they're all, yeah, and see if they would be willing to accommodate us for a while. But then ultimately the contractor is going to have to get a permit from the city.
And then during construction, we will, because their work area is going to be occupy some portion of the street. So if we want to keep the traffic that going through DeHaro, we probably also need to take up that parallel parking spots, which is the number 4 showing here, for about a month or 2 during the construction, so that contractor has enough space to put the wall in. So that's also something, yeah.
That's a tough one. I don't know. I think that's correct. Yes.
Yeah.
We'll make it work.
That'd be great. That'd help a lot.
Yeah. Okay. So Scott, do you want to summarize?
Yeah. So I think the column on the left are the 4 options that we've developed, ranging from $178,000 over budget to $22,000 over budget. And we're delighted you guys love this green solution. We do too. And think it would perform very well. But there's some key decision points that the group probably needs to discuss and make sure we're all happy with. And, one is that the widening of the road to meet the 20-foot City of San Francisco approved accepted street criteria just may not be affordable. And, are we okay backing away from that possibility? That, to me, is a big question. And then, number two here is removing 4-foot 6-inch high wall in option D will allow cost to align with the budget. And let me explain that a little bit. And Faye, could you go back to option D plan, the south portion? Well, this is good. So the yellow area that I'm highlighting here, the cost of that wall is over $22,000. When we do bid documents, it's very common to have like a base bid, you bid what you believe you can afford, and then you sort of have an ad alternate that the contractor also bids, and then the hope is that the base bid comes in lower than we think, and we're able to afford the ad alternate. But if the base bid comes in at our budget, then it may be that this western portion just can't happen right now. So that's one strategy about how to get something built within the time frame that we have for the grant, within the budget the grant allows. Okay, well, let's go to the next one. And then number three is, is it possible to talk to neighbors and ask if 5 parking spaces at 24th and DeHaro can be used by the contractor for staging during construction, plus minus 1 or 2 months? This will save real money for the project. And number 4, contractor to place and remove temporary traffic barriers 12 feet from DeHaro's west curb face to define a safe work zone for them and safe vehicular travelway during construction for residents and emergency use. So it will mean the loss of parallel parking spaces for plus minus 1 month during the day. Is this workable with neighbors? It'll also save considerable money. And then the 5th item here, if the green approach is preferred, are neighbors willing to take on maintenance responsibilities post-construction after the 90-day maintenance period? And, Lila, it'd be wonderful if we could get the grant to do irrigation. That would help a lot. But I do think this is viable even without irrigation. And it could even be that if somebody's willing, that there's like a soaker hose that we lay on top of the wall, and it's connected to one person's, home outlet or hose bib, and it's just turned on, a couple times a week during dry months. But my intuition is pretty well. Go ahead. Right. Great. That'd be great. So that's where we are, and I guess our recommendation would be to pursue option D, and it's kind of unfortunate that it wouldn't be wide enough to become an accepted street by the city of San Francisco, but it'll definitely be wider than what's there right now, and very functional. and I think it's going to look fantastic. And then we bid the western portion as an alternate, and hope the pricing comes in our favor and we can afford it all. Yeah, exactly. Or maybe we even pursue a community challenge grant, next November. And by the time November 2023 comes around, by the time we finish the construction documents, we bid it. Well, let me back up for a moment. I I think it'd be a very good idea if we're all comfortable with option B, is to revise this little presentation and only focusing on option D, without costs, and send it to Ramsey's at the City of San Francisco Department of Public Works. And just sort of make sure that there's no red flags that DPW sees here, since we're working on their land. I think, that's what we did on Carolina Green Space. The answer took a while to get back to us. So, and I think it would make sense to do the construction documents once we knew there wasn't any red flags that they see. So I would suggest that if you're all good with D, that we sort of hone down this presentation to only that and send it to the San Francisco Department of Public Works for a review. Okay. Sure. Yeah, that'd be great. Yeah, absolutely. But that would be our suggestion. And then, hopefully Ramsey says all good and you all feel confident with this. And then we can prepare construction documents and then issue it for bidding. Faye, when we issued Skyline Terrace for bidding, did we send the construction documents to DPW prior to bidding or no?
I don't remember we did that.
I don't think so either. I think once they gave us their preliminary okay, there wasn't anything more required.
Yeah, I mean, because the pricing came back, and then we pretty much changed a lot of things, and I don't remember we sent any updated drawings to the DPW. Yeah.
Yeah, the process or the experience on Skyline Terrace was we did cost estimates working with contractors, sent it out to bids, got bids back, and they're like 3 times what we thought it would cost. So, we've been sending this information to contractors and material suppliers as we go, so that we avoid that. and we know that whatever we draw, we can ultimately afford to build. The 2 contractors we're working with, Gardeners Guild and Crest, neither of them have gotten back to us yet with a review of these estimates. We think they're close, but ultimately we really like them to say, yeah, we're good, and if the construction documents reflect this scope of work, then the bids that we send you ultimately will be close to these numbers. And that would be helpful to know.
Mm-hmm.
Yeah, but construction costs these days are very unpredictable.
Yeah.
Yeah, and labor shortages, and the grant requires that the contractor observe the state of California labor rates, which are a little bit higher than the norm.
Prevailing wage.
Yeah,
Yeah.
prevailing wage, right? That bumps prices up. So anyway, we just want to make sure we're whatever we draw and send out to bid is going to be pretty close to the target, and not go through a painful changing process. Oh, that's where we are. So we can we'll save this as a PDF and send it to everyone, so you'll have it for your get together. If somebody has $114,000 they want to donate before tax day or the end of the year, that'd be awesome too. Yeah, you never know.
Thank you so much. I know it represents so much work, all of this that you walked us through today. So we really appreciate all the hard work and your expertise and your flexibility and creativity. It's amazing. So thank you. Yeah.
You're very welcome. It's our pleasure.
Right.
Okay, guys.
Thank you. Thank you.
You're welcome.
Bye.
Have a good
Thank
evening.
you.
Bye-bye.
Bye.